right, so today you're going to get more practice with inheritance in your labs. We give you a UML diagram, and as long as you design your classes according to that UML diagram, everything should work. If you got started early, and I think it was maybe prior to Monday afternoon or something like that, if you cloned your stuff, make sure that you're looking at that Piazza post. Because you need to get the newer version of the test of the test suite, because we made some changes to that. You could just go ahead and go to the test suite and cut and paste and bring it in, or you can do a proper get pull. It's probably easiest to just cut and paste. But today we're going to be moving on to the fourth pillar of object-oriented programming, which is called polymorphism. Now, polymorphism is supported in a lot of programming languages. It basically relieves you of the need of writing multiple pieces of code to solve the same problem over and over and over again. In fact, it's in the it's from biology. That polymorph simply just means many, poly, and then morph, forms. And with respect to code, it just simply means that one piece of code, that is a variable, a method, or class, can be written generically so that it can be applied to many types, right? Multiple forms, many types. For example, you've seen this in other languages, right? For example, those coming from a Python background, right? How many sort methods do you have in Python? Do you have a sort method for numbers and a sort method for strings and a sort method for students when you create a student class of some sort, right? No, there's only list.sort, or actually, list.sort, right? How does it know how to sort integers? How does it know how to sort floating point numbers? How does it know how to sort strings, right? It just does. It's built into the language. And as long as you design your objects like we did at the very beginning of the first 3 weeks, we made something comparable. We made the person class comparable. Remember that? Here we go. We implement this comparable interface. That means that the sort method can call that method, that compare to, and where is it? Way down at the bottom here. Compare to, and compares this person to that person and is able to order them by last name, and then if they have the same last name, the first name. You can do this in Python too. You don't write a sort for strings, sort for numbers, sort for X. Instead, you write one sorting method and they've already done it for you. You've also seen this in, say, C, right? Do we have 50 different sorting methods? No, we just have what? Hopefully we remember from C. What's the sorting method in C? The sorting function? No? Any C folks at all? All right. Q-sort, right? Q-sort, and what did the Q stand for? Do you remember? Now that you remember Q-sort? Quick sort, exactly. And any other language, for example, Java. We've already seen collections.sort, right? .sort. All three of these are written generically. They can sort anything, right? They just need to be told how to sort it, how to order it. This person goes last name, then comma, first name. And then that person, Zoe, comes after Adam or whatever, right? And we're going to be able to do the same thing. What we're going to do is we're going to write one generic piece of code, one function method that can be applied to any type, okay? There are a couple of different types of polymorphism. We'll get the lesser ones out of the way first. The classic type of polymorphism is called subtype polymorphism. This is the classic OOP polymorphism, right? All it means is that you can treat a subtype as a supertype, right? For example, you can treat a robin as a bird, right? You can treat an array list as a list, right? Why? Because we have that inheritance hierarchy with respect to the collections library. Let me pull that up again, actually. Let's go to iCloud. Here we go. And let me pull this up. Where's OOP? Uh-oh. Did I lose it? Nope. Inheritance, there we go. And where's my big one? There we go. All right, here is that figure again, okay? Remember that an array list can be treated like a list, right? All the way up here. Why? Because of this inheritance hierarchy. An array list is a list. There's a dotted line here from list to abstract list to array list. If you're taking 235 right now, or if you've taken any sort of mathematics before, you'll remember the transitive principle. If you can go from A to B, and you can go from B to C, that means that you can go from A to C. An inheritance hierarchy gives you that transitivity. That an array list is an abstract list. An abstract list is a list. Therefore, the array list can be treated like a generic list so that you can hand it off to the collections.sort algorithm. You could do the same thing with a linked list, but could you do the same thing with a tree set? A set. A tree set is an abstract set, which is a set. Is a set orderable? No. So the way that they've written that sorting algorithm is you have to give me a list and you have to tell me how to order it. I'll take care of the rest. I'll sort everything for you. And again, that is how the collections.sort method works. You can use subtype polymorphism to treat just a simple old array list as a list. Right? Why would you want to do this? Let's go ahead and come back over here to our asset class and take a look at this demonstration that we had before. I filled it out a little bit more here. Right? We've got two different types of stocks, two different types of annuities. Right? Should I have to maintain a list of stocks and a list of annuities? Right? Do I have to maintain these separately? No. Instead, what I do is I use subtype polymorphism. An annuity is an asset. A stock is an asset. Therefore, I only need one list, right? One list to rule them all, my assets. Right? And now I can treat all four of these things as the same thing, right? Because of subtype polymorphism. It simplifies the entire process, right? It simplifies code and means you only have to write one list or one method to process that list or other variables, right? Or other types. And if you only have to write one list or one function that operates on that list, like collections.sort, then that means that you have code reuse, even like an even higher level of code reuse, because we never have to write another sorting algorithm as long as we live. Right? They've already done it for us anyway. Another type of polymorphism, those coming from a C background will really appreciate this. Actually, I think that those coming from a Python background will really appreciate this as well. Except that it's not. I guess it's not that important in Python because you don't have strong typing. But you have what's called method overloading. Right? So for example, those coming from a C background, from C, how many absolute value functions are there? Right? So do you remember? I already asked a C question and nobody answered, so hopefully now somebody is remembering their C. A lot. Abs. That's for integers, right? This is for integers. What if you wanted it for doubles? It's even better. It's even more fabulous. Fabs, right? This is for floating point numbers. That's why it's F in the front. You also have labs, which is for longs, right? Which are double precision integers. You have labs, longs, right? You have 1, 2, 3, 4. Actually, that's not all. There are many, many more than just that, right? And why do you need this? Because C does not have function overloading. Right? If you write a function, only that function can have that name. Right? In other words, once I wrote an absolute value function and I use the name ABS, that's it. No other function can have that name. That's actually the same in Python. Within the same scope, you can only have one function with one name. You can have different varieties of calling that function because you have named parameters and you've got optional parameters, which is something in Python. I don't know if you got that far in Python or not, but you do not have function overloading in Python either, right? Python doesn't have it either, but Java does, right? How many absolute value functions does the math library have? Right? So let's come over here And let's just go into the math library, math.abs, right? Actually, I'll just highlight it right there, math.abs. I see 1, 2, 3, 4, 5, 6. In fact, they all have the exact same name. If I go to math here, let's search for abs, right? Abs, there we go. Okay, fine. Public, static. No, where are my abs functions? Abs. Come on, where are they? All right, I'm going to have to go back over here and finish this out. 5. Take me to that one, please. Right, there we go. Before I do that, actually, come back over here to the asset demo. What did I call it with? What type of value did I give it? An integer. So therefore, it knows, oh, you probably want this function right here called abs that takes an integer. Right? What if I gave it a different value? What if I gave it, say, negative 5.4? Right? Now what type of variable am I giving it? A double. So it probably said, oh, you meant the absolute value function that takes a double. There's also, where are the rest of them? I can force it to become a floating point number. Let's go ahead and get rid of that for now. Over at abs, f, there we go. If you put an f after a floating point number, that forces it to become a float, which is just a lesser double. That's why you shouldn't use it, right? But there, it takes a float, right? There are 7 different versions of this, but guess what they're all named? Abs, right? No confusion here at all. Should I be calling the absolute value function? Well, which one is it? It takes care of it for me. And that's because of method overloading. Method overloading is when you can have one function, you can have more than one function with the same name, right? But with different types of arguments, that is inputs, parameters. Right? How does this work? The compiler is smart enough, I'll put that in quotes because there's no such thing as a smart computer. Compiler is smart enough to figure out which one you want to call based on the value you give it. Right? For example, if you gave it an integer, it calls the int function. It calls the version that takes an integer. If you gave it a double, it calls the version that takes a double. Right? This mechanism is known as static dispatch. Right? So what does a static here mean? It doesn't mean like it means in Java where you've got a public static void whatever, right? It means it means something completely different. It means at compile time, right? This is the compiler being smart enough to figure out which one you wanted. Just like me clicking on it over here. Oh, I'm giving this a floating point number. Therefore, if I click on this, it takes me to the version that gives me a floating point number, right? There's nothing smart about it. It's just process of elimination. Is there a version that takes a string? 10. Right? No. Static dispatch here fails because it says, okay, you want to call the absolute value function. There are 7 versions of it, but none of them take a string. Therefore, compile time error, I can't do this. Right? There's no such function. The compiler is able to figure that out at compile time, which means that it is a static dispatch, right? The compiler dispatches the function call at compile time. Compile time, right? That's what static means. That's what static means. The opposite of static in this context is dynamic, when the program is actually running, because it's not just a bunch of static code, a bunch of fixed code. It is code that has been compiled and is actually running, right? It's more dynamic that way, or it's dynamic, okay? So that's called method overloading. There is also operator overloading, right? So consider in Java. This is the same in Python, by the way. What if I do the following? What if I do string plus string? Right? Now, does this plus operator here, does that mean addition, what we normally think of when we think about mathematics? No, what does it mean? So what do we call that when we take 2 strings? There's a special name for that. Concatenation. Here, the plus means concatenation, right? But what about a different situation where I've got, say, an integer plus an integer. Right? Here, the plus operator means ... what it means in mathematics. What is it? Addition. Here's a good question. Int plus string. Here, the plus operator means what? Oops, sorry, plus operator means ... what? When I mix these two types together, I've got an integer and I've got a string. What's it going to do? All right, let's find out. All right. So, int x is equal to 10. String y is equal to 10. Right? And, oops, spell it correct. String. There we go. And then, I don't know, foo, or string y, excuse me. There we go. Foo is equal to x plus y. What is foo going to be? I need to create this variable, right? Foo. So if I create that variable, what type is it? String. So in this context, what did it mean? Concatenation, right? After converting the int into a string, right? So concatenation, but it does an extra step under the hood. Those coming from a C background, is this even possible? Is it possible for operators, say plus, equals, the assignment operator, multiplication, etc., to have more than one meaning? Is that even possible? No, right? What about Pythoners? Right? Let's go through the same exercise here with Python. What if I had, and we don't have types in Python, but if I did a string plus a string, what does that mean? It means, hopefully we know in Python, concatenation, right? All right. What if I did int plus an int in Python? Addition, right? What if I did this, int plus a string in Python? Not possible, exactly. This is a runtime error, right? You cannot mix types in Python, right? So we have one language where we have operator overloading in some cases, where one operator can have different meanings depending on the context. In another language, we don't have this at all. Why? Because C is not an object-oriented programming language. It has no concept of overloading at all. In Python, we have it kind of. In different contexts, it means this thing. But in another context, it means something completely different from, say, Java. Right? And then, of course, you have something like C++. Right? You can overload anything you want to have any meaning you want. Right? For example, you could overload the minus operator to mean addition. Right? What kind of a stupid world would we live in where when you program something and you typed out A minus B, it would end up adding those two things together? Right? Why? Because C++ has full operator overloading. You can do whatever you want to whatever you want, and it's chaos, right? This is generally a bad idea. Because, what does it mean, right? What if I did the following? What if I had a list, example? What if I had a list plus a list? What does this mean? Right? If I want to take one list and add it to another list. There are lots of different interpretations here. Right? How would you interpret that? Can you do that in Python, by the way? Think you can? I don't think you can do anything like that in Python, can you? No. You can't do that in C, certainly, right? Say what?
I'd probably append the second list to the end of the
Okay, appending the second list to the end of the first. All right. So you would interpret it as appending. There are completely other valid, interpretations of this. For example, vector addition. All right. Add each component producing a new list. For example, if I had A, B, C, and X, Y, Z, my new list would be A plus X, B plus Y, C plus Z. And now I've got a new list with 3 numbers in it, right? That's what vector addition would be, right? It could be, and now a lot of you are in 235 right now. Have you done sets already? Right? No? Well, you can take two sets and you can union them together, right? You can add them together. You can take an intersection, maybe, I don't know. A whole bunch of other things. In other words, it is completely ambiguous. Right? And in a programming language like C++, you would have to write code to determine what this means to begin with. And if you have to write code to determine what this means to begin with, you might as well put that into a function with a much better name. Append lists, vector addition, union, intersection. If you had functions that actually did these things, you would name them appropriately, right? So it's kind of useless. Here's another example, right? What if I had, say, time plus time, right? What does that even mean, right? So if I took February 21st, 2024 plus, I don't know, March 30th, 2005. What does it mean to add those two things together, right? Who knows? It's meaningless, right? Are these points in time, right? Are these durations of time? Are periods of time, right? And you see that if you get into starting to use the time library with local date and stuff like that, then you can start computing, actual number of days, number of years, and stuff like that. But they all have different concepts. A duration is not the same thing as a period. A period is not the same thing as a point in time. You can't just add these things together willy-nilly. You need to call the correct functions that say take one time and another time and returns the number of the duration between those two times, or the period between these two times, right? So at the end of the day, operator overloading is a thing, but should be limited. Extremely limited. The only time that you are ever going to encounter something like this to any extent would be in C++, where you can do whatever you want, right? And it's recommended that you don't do it. With great power comes great responsibility, right? And if you start screwing things up in C++, it's not going to be well designed. Thankfully, Python, Java, C, they limit these. Either they don't allow you to do it at all, or they only have very specific instances, say with mixing strings and other types, in which it actually works. Right? At the end of the day, it's just syntactic sugar anyway. Your plus code, like over here, this plus code is actually replaced with other code. This code gets replaced with something that looks like this: new string builder, right? Dot append x. And x is, so integer dot toString x, and then dot append y. Right? So this line up here will actually end up being something like this. Foo is equal to, and then I guess toString. Right? The compiler takes your code and says, oh, plus, you want to go ahead and concatenate these two strings together. You just wanted that plus for convenience. I'm going to go ahead and replace your code with code that looks like this instead. There's no plus here at all. It's function call, function call, function call. Right? And that's why it's really just syntactic sugar at the end of the day. Right? Your code ends up getting replaced to something completely different that doesn't do that thing. Right? All right. Okay. The other type of polymorphism is probably the most powerful type of polymorphism, especially in Java. It's parameterized polymorphism. In Java, you can create a parameterized variable, class, or method, right? So that one method, that one variable, can be any type, right? That method can act on any type, or that class can be associated with any type, right? That's pretty cool. If we have a demonstration over here, I'm going to go ahead and open up this file now. We've seen this before already with, say, array lists. So I'm going to go ahead and create a list. In fact, I'm going to go back in time about 20 years. Before parameterized polymorphism was introduced into the Java programming language. I'm going to have a list here called stuff. right? Because I don't know what I'm going to put into that list, is equal to new array list. There we go. I don't have any parameterizations there at all. This is complete chaos. What can I add to stuff? I can add 42. Stuff.add. I can add hello. Right? Stuff.add. I can add whatever I want to whatever I want. Let me go ahead and come over here and grab a piece of code. I'm going to create myself here. And I'm going to go ahead and add myself. Right? There we go. So what does this list now hold? It holds an integer. It holds a string. It holds a person. Stuff.add 10.5. Right? It also holds a floating point number here. Right? This is what's called a mixed type. Now, for those coming from a Python background, you're going to see, you're not going to see anything wrong with this whatsoever. Because if you've got a list in Python, what can you put to into that list? Anything you want. You basically have what we've done up here. This is chaos, right? In C, can you do anything like this? Definitely not. When you create an array, you have to specify this is an integer array, this is a double array, this is a character array, right? You have to say that this is a specific type, right? And back here in the Wild West of Java, this is what you had to do, right? Can I add anything together over there, right? For what? What in X in person, or not person, but stuff, right? What can I do with it? What can you do with X, right? So first of all, what type is X? It's just an object, right? I can parameterize it like this if I do something to it first, but we're not there yet. It's just an object. Object X in the collection stuff. What can you do with X? Not much. You can only do whatever an object has. The equals method, the get class method that some of you have been looking at, the toString method. I could print it out, but that's pretty much it. System.out.println X. Right? Why am I able to do that? Because up in the object class, it has a toString method defined there. Where is it? toString. All right, fine. We'll come back over here and jump to it immediately. There we go. What's the default behavior here? The default behavior is to just convert the memory address, the Java virtual memory address, into a hex code. So over here, though, when we actually run this, of course, 42 is an integer. It's got its own toString method. The string has its own toString method. It just returns itself. This will get coerced into a double and output properly. Right? So everything is proper. Right? Why does it output Chris, Burke? Because I got these wrong, right? Burke, Chris. There we go. And why does that work? Well, because we did our own toString method. Right? Remember that we generated this and then modified it. So pretty much all you can do is treat them as objects. Is that very useful? Right? I mean, if all you ever want to do is print it out, then fine. Right? But is it? Right? What if you wanted to add them together? You're not able to do that. So they introduced later on list in parameterizations. Right? That's where this Langle wrangle is coming from. I'm going to state that this list is for integers only. Right? Integers only equals new array list. Right? And now I can add 42, integers only. Right? Dot add 42. I can say integers only dot add 101. And it will fail if I do integers only dot add hello or me, right? Integers only dot add the person. Right? Why? Because I specified that this list is only for integers. Okay? That is a parameterization. I'm not able to do these things now, right? Now some order has been restored to this chaos. I'm only, if I create a list of integers, it can only hold integers. Therefore, I have a minimum amount of information. What can I do with this now? I can iterate over it for integer x in integers only. I can add them up. Plus equals, x. Of course, I'll need a total. Int total is equal to 0. Right? And let's say system.out.println total. There we go. Now I can actually do something with it because I have a minimum amount of information about what is in this list. Let's do the same thing for a double. List of doubles, right? Doubles only, right, is equal to new array list. Now, can I add strings? No. Can I add people? No. But doubles only, I can add 10.5. I can add, I can add pi, 3.1. Well, let's go math.pi. There we go. Just get some more practice there. Doubles only dot add 10, right? It doesn't work. Why? What is 10? It's an integer. Can I add an integer to a list that I called double that I said only doubles are in there? No. So one thing that I could do is I could go ahead and put a 0.0 behind it, or I could put an F behind, or a D actually, D behind it. The D says I don't care what I wrote. Yes, I wrote 10 and without a 0.0. Force it to become a double, or I could go ahead and do this. I could force it to become a double that way using traditional typecasting. Okay. But I'll go ahead and go with a proper 10.0 here. Right? Okay, I can still add those up. Let's add those up, and my total here, I will say that it's a double total, and I'll call it D instead, because I need a different value there. Doubles only, and double X. Right? So I'm getting both of those now. But wait a second, I don't want one for loop to work for doubles. I don't want one for loop to work for integers or floats or longs or any of the other numbers that are built into Java that we're not going to cover. Another alternative is to create a list of numbers. Numeric, I think it is. Right? Any number is equal to new array list. It's not number, it's number. Come on, number. Yep, there we go. So what is a number? A double is a number. An integer is a number. A float is a number. A long is a number. Right? Is a. What should that be bringing to your mind right now? Inheritance. Right? Just like a robin is a bird, an ostrich is a bird. All of these things are numbers. And any number, I can go ahead and add 10 because that's an integer. An integer is a number. Any number dot add 10.05. Any number, right? And math dot pi. Right, pi. Now, if I were to put this sum total into a function, I don't have to write one for a list of integers. I don't have to write one for a list of doubles. What I can do is I can write one for a list of numbers. Public static, say double sum, right? And I will take a list of numbers, right? Values, and there we go. There's the total, not the doubles only, but values, right? All right, values and number. There we go. I do have to make some changes here now, though. Because this is a number, I can't just go ahead and add it to this. What I need to do is I need to get the double value. Right? If you have an integer, there's this function called double value that converts it over to a double and gives you the double value of it. Right? And instead of printing it out, I will return total D. Right? And actually, I don't like total D anymore because this is a new function. So let's go ahead and refactor, rename to total. Oops. Why didn't it take place all over the place? I don't know. It just failed. Oh, because it's not compiling for that reason. It wasn't not able to recognize it. I can't believe I typed a parenthesis instead. Right? I saw a rant on programming humor the other day. This is not a bracket. Right? I don't know who would ever call that thing a bracket. This is a bracket. This is a curly bracket. These are square brackets. This thing right here is not a bracket. It is a parenthesis. Right? But now it's a curly bracket. Okay. So I can make this more generic by using polymorphism, and I can, and in conjunction with subtype polymorphism, to write one sum function and never have to worry about this again. So let's call that function now. Double total is equal to, what did I call it? Sum? Sum of any number. And then print it out. System.out.println total. I'll call it foo because I'm already using total up top. Foo and foo. Let's run this again. There. Do I need to do this for doubles? Let's go ahead and replace this. Right? And let's replace this. Instead, I'll just have a total, double total. Right? And I will call integers only. Total is equal to, once again, this thing right here. Sum of integers only. I'm going to try to do this. It's not going to compile exactly, but we'll fix that here in a moment. And I'm going to have doubles only. And then print out the total, print out the total. Right? So that I only have to write one sum function. That would be nice, but it's not actually compiling. It only works when I've got a list of numbers. Why is that? Because I said that it only works for a list of numbers. Right? So I'm back at square one. Maybe I need a sum function for doubles. Right? Maybe I need a sum function for integers. Integer values. Would I have changed any code inside these functions at all? No, they still iterate over it. I guess this. This would become integer. This would become a double, right? But otherwise, it'd be exactly the same. I wouldn't be able to use the same name anymore. I'd have to call it sum A, B, and C. And now I'm back at square one in 1979 with C. I can't have multiple absolute value functions with the same name because we do not have function overloading. Right? This doesn't seem like the best solution. Right? So what I'm going to do is I'm going to parameterize this. There we go. I'm going to parameterize this function. Okay? Before I do that, let's go ahead and look at what a parameterization means. Int x is equal to 10. There are three parts to this line. Right? What are the three parts? The type of variable, that's the first part, an integer. The name of the variable. What's the name of this variable? X. The value of the variable, which is going to be 10. Right? There are three parts in just this one simple line here. Let me show you what a parameterization looks like. T, Y, right? There we go. I don't have a value anymore, right? What is the type? The type of variable, right? Question mark, question mark. The name of the variable is going to be Y. That's pretty clear. What about the value of the variable? Right? For that, nothing yet. In other words, nothing yet in Java is what? If you don't assign a value to a variable, it becomes a null, right? Okay, so we've answered those two questions. That's pretty straightforward, but what about this one right here? What type of variable is that? It doesn't compile yet, but it will shortly once we make our changes, right? What type of variable is this? T, right? In other words, generic, right? It can be any type. It all depends on how you use the code. In other words, variables, their types can also be variables. All right? Let me show you what that looks like up here with this sum function. Right? T. A list of t's. Right? Now to do this, I'm going to have to parameterize it. So I'm going to say that there's this t here. Okay? Well, what type of variable is x now? It's not a number, it's not a double, it's not an integer. What is it? What did I say that this is a list of? T's. Fill in the blank. We're still not there yet because there's something else that we need to do. But when you call this function and give it a list of integers, what happens? All those t's then get replaced with integer. When you call this with a list of doubles, what happens to all these t's? They become doubles. When you call this with a list of numbers, what happens to all these t's? They become number. Magically. Right? Why? Because it is a variable. The type is variable itself. So let me restore all of these to just a generic t. Right? Okay. So we still are not there yet. Why? Because what do we know about t right now? We're back at square one down here when I had a list of stuff. What do we know about stuff? Nothing, other than it's an object. So what do we know about t here? Nothing, other than they're an object. Do objects have a double value? Does it make sense for a person to have a double value? What does that mean? Is it my height? Is it my weight? Is it my age? What is? There's no meaning there at all, right? I suppose you could give it meaning, but you'd be programming that, right? And then you still wouldn't have it because this is an object. And objects don't have double values. They have two string methods. They have equals. They have get class, but they don't have anything like this. So what I need to do is I need to say that this is, I need to give this a little bit of information. If you're going to sum up a bunch of numbers, what do you need to know about it? That they're numbers, right? So I'm going to say that T extends number, right? Oh, that's weird. I'm getting emoji stuff from the chat. All right. Python to create a virtual supermarker. Okay, I don't know what that means, but all right. Go ahead and expand on that in the YouTube chat if you know what that means. All right, so now I do have enough information. T extends number. Now I know that it's a number. And if it's a number, it has a double value, right? Let's take a look at down here everything is solved now, right? Except for that down there, right? I'll take that out as an example for now. But let's look at this first one. Integers only. I'm calling that one sum function, giving it integers only. Doubles only. I'm calling that one sum function with doubles only. Any number. I'm calling it with any number whatsoever. Right? In other words, 1, 2, 3 problems have been solved. In fact, more problems than that have been solved with this one parameterization. T extends number. This can be whatever, right? This can be a list of numbers. This can be a list of not strings, excuse me, but a list of integers, a list of doubles. I've solved this problem once and for all, and I never need to write another function to add up a bunch of numbers. That's actually really cool, right? I don't have to write 50 different versions of the same function. All I have to do is parameterize it, and it gets the job done for me. You don't have to write 50 different lists. All you have to do is write one list and parameterize it to take any type that you want. In fact, let's take a look at what that looks like up here. It's probably an abstract list, actually. We're going to have to go up to abstract list. Right? There, we've got a parameterization here for E. E stands for element, the type of element. And what does it have at the end of the day? Where is it? Where is the? Okay, maybe we have to go back. Maybe it's over here. There it is. Nope, that's not it. Come on. Empty element data. Where's the actual element data? Size. It's somewhere around here. Darn it, where is it? Empty element data. Default capacity. Nope, that's static. There we go. There it is. I just was not able to find it really quick. Element data. How is it being stored? It's being stored as a bunch of objects. But because it is parameterized up here to take E, when you create a list over here in our demo class of integers, that E gets replaced with integer. When you create a list of doubles, that E gets replaced with double. It gets replaced with number, just like our function up here. That T gets replaced with whatever you're trying to call on it. So you only have to have one function and that's it. Right? You've solved that problem forever. Again, polymorphism. Polymorph, many forms, up here. Right? One piece of code, a variable, a method, or a class that can be written generically so that it can be applied to many different types. In this case, I've applied it to floats, doubles, integers, longs, shorts, bytes, and numbers. I've written one function to solve 7 problems, right? And any future problems that I might encounter, right? All right. Any questions on that? Otherwise, we'll review it on Friday. Yeah, go ahead. Way back there.
What is x dot doubles? What does that matter for?
Sorry. Up here?
Yeah.
X dot double value?
Yeah.
That is an abstract method of the number class. And then in the lower classes, the big D double, the big I integer, they just return a copy of themselves, right? So it is a function that allows you to convert any number into a double because the double is the most generic type, right? But actually, it's not the most generic type. I could also have, say, big integers, right? X is equal to new big integer dot value of. And then here, I'll mash my keyboard, right? Is that a number that you could store in a typical integer? Nope. But it's a big integer. Dot value of, come on, it should be like that. It should be string, maybe it's 10, base 10. No, okay, there's a way of doing it. I'm not going to remember off the top of my head, but I could have a big integer, and then a list of big integers, and I could add them all together. Right? Now, it's not going to work to give me a double value here because that big giant number is not going to fit into 64 bits, but you get the idea. I could probably write this more generically like super number. Super number. That includes all of them, but I'm not going to do that. Right? I'm just going to take care of the small numbers. Right? But double value is converting any number into its double equivalent. Right? 10 gets converted to 10.5. 10.5 stays 10.5, etc. All right, we'll go ahead and pick it up from there on Friday.